Hello everyone, today we're starting section 2.1, chapter 2 now, relations and functions. Again, always feel free to pause the video if you need to get caught up writing something down. So let's get to it. For every input of a function, there is exactly one output. The definition of a relation is a set of ordered pairs of inputs and outputs. So a function is more of a more specific type of relation. Relations are very general. Just, hey, we've got inputs and outputs. We're relating this with that. But a function is a little bit more of a specific type. Every function is a relation, but not every relation is a function, if that helps. So looking at the set of ordered pairs here, we can imagine the input is all of these first ones, all these x values. You can see these are the x's, is the input, the domain, and the output are all the y values, or also called the range if you are talking about all of them together. Okay. Circle the output values in the relation. So all the output values are the y ones that come second. So circle this one here. I'm not going to zoom in that much. Circle the 3, this 2, and the -4. Okay, write the domain of the relation. So the domain would then be, what do we have here? We have a -2 and 5. So because -2 gets repeated twice, we technically don't need to write it out twice. We just only write it out once. So when we do this, we actually use these kind of curly, you see these little curly brackets? We use those to start a set of inputs or outputs, our domain and range. So we're going to do -2, comma, and then we have a 5 is our next x. And those are the only two x values we have. Those are the only two numbers that are going to be in the domain. So that's all you have to do. You just list them out. Okay. Representing relation. The average water temperature of the Gulf of Mexico and Key West, Florida varies during the year. In January, the average water temperature is 69 degrees Fahrenheit. In February, 70 degrees Fahrenheit. March is 75 degrees Fahrenheit. And April is 78 degrees Fahrenheit. How can you represent this relationship, or just relation, in 4 different ways? Okay, this section's big about representing the same type of information but different ways. So this first one we have, this is called a mapping diagram. How do I like to remember that this is mapping? I see the arrows, and if you look at a map, you're kind of always looking at, okay, I'm right here, and I want to get over there. So if you imagine kind of getting like the arrows are directing you to where to go on the map, that's one way you can remember that this is called a mapping diagram. So January, arrow 69, because the January and 69 went together. Sometimes I might say get sent to. So February, okay, these are all the inputs here. These are all the input, and these are all the outputs here. Okay, so February is 70. March was 75. And what was April? 78. So I gotta zoom in when I write. April is 78. Okay, so that's a mapping diagram. You should already be familiar with ordered pairs because you've graphed lines before in Algebra 1. So February, comma, 70. Then it was March was 75. And then April was 78. Okay. So we got the mapping diagram. We've got ordered pairs, which you should have seen before. We've got tables, actually, which you've seen before. So we can just fill this in. Same thing. 70 is for February. March is 75. April is 78. And then just a regular old graph. Okay, just put the dot for January is, what was that, 69. I'm just going to eyeball it right about 68. Oh, it's actually probably right smack dab in between. February is at 70. March 75. Where are you at? Right about here. Then April was 78. There we go. So actually, of these 4 different ways we just did, mapping's probably the only new one. That one's a little bit more not used quite as much. Okay. Finding domain and range. What are the domain and range of the relation? So, again, domain is the set, is the ordering of every single x value. Usually we like to do it in numerical order. So I see -3. Here it is domain. I see -3. I see 0, 2, 9, 23. Looks like they're actually already in order from like least to greatest. So I'm just going to keep that same order of, whoopsie, of -3, 0, 2, 9, 23. Just listed off every x value there. Now I'm going to write all the y coordinates. Are they in order? No, but it looks like they already put 14 first, so they already messed up going least to greatest, so it doesn't matter. It's not a big deal. I'll just go in the order that I see them at: 7, 0, -18, and -99. Oh, I guess it's in order of biggest to smallest. That's okay. Okay, completed sentence. The set of x coordinates is the, said a few times probably already, domain. That's domain, just by definition. And the set of y coordinates is the range. Okay. Again, when we say set, this word set, that word actually, low key, has the most definitions in the whole entire English language, I'm pretty sure. There's lots of sets. You can be a director on a movie set. You can set something down on the table. There's a lot of different definitions for it. The set of math is just a collection of items, pretty much. We're just listing off all of these things. That's a set as well. Okay, identifying a function now. So we've listed off. We've so far have just kind of been having relations, and now this is a special type of relation, a function. It's a more specific type, where, again, if you remember from the very first thing we talked about, each input has exactly one output, okay? So let's see if we can figure one out. Circle the range values that correspond to domain value 2. Let me see here. So we have domain value 2 right here. This is a mapping diagram. So 2 actually has 2 different outputs. It gets sent to this -3, and it gets sent to +3. So we have 3 and +3. Sorry, -3 and +3. So every element in the input corresponds to exactly one element of the range. No, that 2 gets sent to 2 different spots. So that's false. And the relation is a function. Also false, because literally it says exactly 1. It needs to go to exactly 1, but the 2 is getting sent to 2 different numbers. It has to only go to 1 number. Okay, that's it. All right, moving along. You guys might have done this before, but there's something called the vertical line test, where, let's say, if we don't have just numbers here, if we don't have like a mapping diagram to literally see the arrows or ordered pairs, and we just have a graph. I mean, I know technically in a graph we could list out all the ordered pairs, but there's a ton in here, and that would take a long time. Very fast way to do this is just draw a vertical line. Just draw a vertical line. Sometimes if you want to be safe, you can actually draw multiple. I'm going to change my color. You can draw multiple vertical lines if you want, just to make sure that you don't accidentally miss it. And the thing is, if you draw a vertical line, and we're looking for, are we hitting the graph multiple times? Are we hitting the graph multiple times? That's like saying, each input has multiple outputs. Because if you imagine this x value here, whatever it is, let's say this is like, I don't know, like 1, 2, 3, let's say it's like around 4 or 5, okay? That one x value would have two different y values. I don't know what it is up here, but this is like, it could be 1, 2, 3, 4, 5, 6, 7. So this could be 4, comma 7 as an ordered pair, and then this would be -1, -2, like -3, and 4, -3. That one x has two different y values. That's not good if you're trying to be a function. So this one is a no. This part B here, which is a bunch of dots, you can draw some vertical lines. It doesn't matter where you go. It looks like I'm only going to hit one dot each time, so that's good actually. And here, if I draw a bunch of vertical lines, nowhere along this graph does it hit it twice. Okay. So underline the correct words, complete the sentence. If a vertical line passes through more than one point, the graph does not represent a function. So which ones were not a function? Just graph A here. That was the bad one. Okay? All right, using function notation. For f of x equals -4x plus 1. Again, that's kind of the same thing. You might have heard y and f of x are like the same thing. You've probably graphed lines like this before. Okay? We're just getting a little bit more fancy, a little bit more professional, a little more upper high school, collegey with the f of x notation. So what it means is if we replace the x with a -2, instead of f of x, but now it's f of -2, we're kind of saying, hey, plug in a -2 for x. That's what that's saying. So that input is -2, and we want to plug it in. So f of -2, you're plugging in -2 for x here. You also plug it in for the x in the actual expression equation. Let's see here. This is -4 times -2 is 8. 8 plus 1 is 9. Not too bad. We just used the function notation. All right, what we got here? You are buying bottles of sports drink mix for a softball team. Each bottle costs $1.19. Right? What function rule models the total cost of a purchase? Evaluate the function for 15 bottles. So C is going to be, what do we want it to be? Well, we're talking about the number of bottles here. I don't know if I don't like the choice of the letter C for that, but that's what that's what we have here. So we have a number of bottles bought. Again, I don't know if I would choose the letter C for that. But the function f of C, the function evaluated at the number of bottles bought, that would equal the total cost. Okay, so the total cost, which would be f of C, would equal the cost per bottle, which is $1.19 again, times C. Times C, the number of bottles bought. So, in general, we have f of C equals just $1.19C. And now if they want to evaluate that for 15 bottles, how much would that cost? The function evaluated at 15 would equal $1.19 times 15, which I'm just going to plug into a calculator real quick, and I'm getting $17.85. Yes, could you have figured this out without the fancy function notation? Sure. But this is just getting a little bit more fancy, and it is used a bunch, this notation, so we gotta get familiar with it and understand what it looks like and how to work with it. Okay, I think I'm actually going to stop right there. So head over to the Math Excel. Have a great rest of your day. How do I turn this off?